this recording for ICP-3 for me, Lyle Vanfossan, and Scott Brunton. So I'm going to be talking about the first couple of things. So on the top part here, we have our dependencies and setup. So it's just pulling in all of our various libraries that we use, NLTK, Spacey, WordNet from the NLTK corpus. And also we set up our Spacey loader here and also get our document here, which is just 4 sentences. A woman is walking through the door. She asks for directions to the elevator. John is a man from North Dakota, and George likes to drive his car. So we're going to run this. And this should all be set up pretty quickly. Okay, so the first thing in this example is triplet extraction. So the first thing we are going to want to do with the triplet extraction is we're going to want to grab all of the noun chunks in each of the sentences. This is already ran, so I'm not going to go ahead and run it again. But for the first sentence, you can see that the noun chunks that were extracted were a woman, the door. The next one, she, directions, the elevator. John, a man, North Dakota, and then George in his car. Actually, I think I need to run this again because one of those sentences was not in the list that we had above. Okay, so the first thing we're going to do for triplet extraction is we are going to go through each of the words in these noun chunks that we have, and we're going to search through the ancestors of those until we find a prepositional word. So like a prepositional word is going to be like through or for or of, something like that, that implies that there's a relationship between two entities. So when we go ahead and run this, we wind up with walking through and asks for. So that is actually not all of the relationships that we need for the sentences above. Walking through and asks for is actually just for the first 2 sentences. So woman walking through and then asks for. So the issue here is that we were looking for these prepositions, but in the last 2 sentences, there actually aren't prepositions that are a part of those children. So we've explained that here, and you can see a little bit when we run this that there actually are some relationships here whenever we just run through the sentences and we grab the text of the head of the sentence, the child text, and then we list throughout the children. So you can see here is man a from and then likes to drive cars. So these relationships exist, but it's just a matter of us actually formatting those into one of the parts of the triplet. So in this next part, essentially what we're doing is we are going and grabbing these items, this root head, the child, and then the ancestors of the child as well, and we're formatting those into the correct order. So whenever I run it, we still have our original relationships. We have walking through and asks for, and now we have is from and likes to drive as well. And then finally, now that we have all of these relationships and we also have all of these noun chunks, we're going to run this last bit of code here, which basically just takes each of the noun chunks and combines them with the relationship that we derived here. And in doing so, that will give us the triplets. So we have a woman walking through the door. She, which actually is for a second sentence, she asks for the elevator, and then she asks for directions. So there's actually 2 connections there between the woman and the elevator, and then the woman directions as well. So we get those 2 different triplets. And then we get John is from North Dakota. A man is from North Dakota, which is similar, where we have 2 different relationships between 2 different noun chunks. And then finally, George likes to drive his car. So that was our triplet gathering. I'm going to go ahead and pass it off to Scott, who's going to talk a little bit about some of the WordNet functionality. And Scott, go ahead.
So for our WordNet test, we I'm just going to explain the logic we used for the first 4 tasks, because the logic's essentially the same for each of them, but they just have different lexical calls that they're making, lexical relationships that they're displaying. So the first thing that we did was we took our doc sentence and we split it out per sentence, then split per word. And then from there, we were gathering the sensets that were used for each individual word. And we were taking the top value from the senset, which returns the parts of speech as well as the probability level. So we were taking the one with the highest confidence level, which happened to be the first one in the array, and then displaying it and making the call for, in this case, our hypernyms. And while we were here, we also displayed our hypernym's distance, which was the distance it was from the root node itself. And then we can see we have the same logic here as well. We're displaying, but in this case, we're displaying the hyponyms. And you can see that as we go through this, the results are going to be less and less as we get further down, based on just the way the lexical relationships are displayed, are created, I'm sorry. So. Yeah. And then here we have the meronyms. And then the last one that follows the logic is the holonyms itself. See, we have the least amount of results here.
I think I also have entailments here as well.
Yeah. Yes, thanks, Lyle. The entailments actually have the least amount of results, but entailments, we did have to create that just a little bit different because there was so few results returned. So where for the previous four, we were taking the first synset that had the highest ranking and just working off of that and displaying the WordNet task off of the highest ranking one. For this one, since there were so few values returned in our entailments, we went ahead and used every synset that was available and still only ended up with a handful of results returned. So, and the way we had to approach this was we would take every single synset and then we had to make a conditional comparison to make sure our entailments weren't blank because well, there was a lot of them, frankly. But yeah, we start with our synset that compares to make sure we did not have a 0 or a null synset return, because otherwise it would display as an out-of-bound array. Then we would have our entailment check to make sure it was not a null, just because there was a ridiculous amount of those returned as well. And that was everything for the WordNet itself.
Okay, well, thank you very much. And we're going to cut the recording.